So now we're going to use what we learned about differentiating by, or integrating by parts to integrate this expression, x times sine x. This is probably one of the easier questions for integration by parts, but I'll run it through you guys and show you guys some of the basics. So let's just remind ourselves over here in the corner that the integral of u times dv is equal to uv minus the integral of v du, and you can check out the previous video for a proof on that. So let's get back to our question. So what I like to do is keep everything nice and neat, and we know we're going to be needing 4 different variables throughout this question. We have a u, the derivative of u, v, and the derivative of v. And if we can find all these, that makes doing this problem pretty easy. And when you're trying to figure out what you want your u and dv to be, because this expression, as we see here, is just a u times a dv, you really want to think ahead. Do you want to anti-differentiate x, or do you want to anti-differentiate sine x? Well, if you anti-differentiate x, you're going to get a 1/2 x squared, which is not as nice as the antiderivative of sine x, which is simply negative cosine x. So we're going to go ahead and put the x as our u and the sine x dx as our dv. So now we can go ahead and fill the rest of our variables. And remember, to get from u to du, we just take a derivative, and from dv to v, we just take an antiderivative. So let's do that. The derivative of x is simply 1 dx, and the antiderivative of sine x is simply negative cosine x. So pretty much now that we have all these figured out, the rest of the problem is just a plug and chug. We have this equation right here, and we're just filling it in with these values that we figured out. So let's go ahead and do that. So this is a problem. X times sine x dx is equal to u times v. Well, we have them simply laid out right now. So use x times negative cosine x, and now we need to subtract the integral of v times du. So that's negative cosine x, and our du is 1 dx, so I'm just going to simply write dx because the 1 doesn't change anything. And so we have a little problem here, so we can keep on simplifying this question. So distribute negative sine negative x cosine x minus, and then the integral of negative cosine x is negative sine x. Let's simplify this even further. We have negative x cosine x minus the negative plus sine x. Since this is an antiderivative, never forget to add c. So that's pretty much it. But quick thing we can do is check our answer. Since this is the antiderivative, we know that if we take the derivative of this expression, we should get that expression. So let's do that real quick. So let's start off with this negative x cosine x, and we can use the chain rule. So that turns out to be the derivative of, let's keep this negative out here, forget about it for now. The derivative of x, which is 1 times cosine x, which is just cosine of x, plus the derivative of cosine x, which is negative sine x, times x. So we get negative x sine x. And then we have the derivative of sine x, which is cosine x. And let's see what this turns out to be. Distribute the negative sign. We have negative cosine x. And then we have a negative plus a negative. So that's just going to turn into a positive x sine x. And look at that. We have negative cosine x plus cosine x. Bye-bye. And we are left with x sine x, which is our original problem. So that's a quick problem, one of the easier problems using integration by parts, and there will be some more difficult problems in the future.